We have already discussed that real numbers can be classified in two types. One is rational number and another is irrational numbers. And under rational numbers comes all the integers, in fact all whole numbers also, and all natural numbers. And natural numbers are the counting numbers that starts at 1 and it goes up to infinity. And whole numbers are natural numbers along with number 0. So this is the set of whole numbers. And in integers, all natural numbers and negative of all natural numbers including 0. This is the set of all integers. Rational numbers are basically the fractional numbers, and we'll discuss more on rational numbers in this part, and irrational numbers we'll discuss a bit later. Let us define rational numbers. We can understand rational numbers from this word rational itself. The word is RATIO, ratio, NAL, nel, ratio, nel. Rational numbers are somehow related to the ratio. A rational number represents a ratio or fraction of two integers. In fact, the term ratio is derived from the word rational, but word rational is not derived from the word ratio. Now let us define the rational numbers. If a number is expressed as a clear ratio or fraction between two integers, it is a rational number. Now we can define rational numbers in a very short form. So we can define P upon Q is a rational number if P is an integer and Q is also an integer, but Q must be a non-zero integer. So in mathematical form, we can write whole definition is a very short form. P upon Q is a rational number. That means P upon Q belongs to Q if both P and Q are integers, belongs to I belongs to integers, and Q is not equal to 0. So this is the complete definition of rational numbers. So it explains everything. It says that if a number can be expressed in the form of P upon Q, where P and Q are integers and Q is not equal to 0, then those numbers are called rational numbers. Let us take one example. Say you take any number. Say we take one integer -3. This -3 is equal to, it can be written like this, -3 upon 1. So this is in the form of P upon Q, and P, Q both are integers and Q is not equal to 0. So this is a rational number. Now let us take one example from the whole numbers. Say 5 is a whole number. This is equal to 5 upon 1, and this is also in the form of Q, and it fulfills the condition that both P and Q are integers and Q is not equal to 0. Now let us take another whole number 0. 0 is equal to 0 divided by anything. Say 0 divided by 2. So this is also in the form of P upon Q, and it also fulfills the conditions P and Q are integers and q is a non-zero integer. So all the numbers which can be expressed in the form of p upon q, where p and q are integers but q is not equal to 0, are called the rational numbers. Rational numbers can be expressed as decimal number also. Let us take some example. So 1 by 2, 1 by 5, 1 upon 8, all these are fractions. So these are in the form of p upon q. So they are rational. They can also be expressed in decimal form. See, 1 upon 2 is equal to 0.5. This is equal to 0.2 and 1 upon 8 is equal to 0.125. Now, if we take these examples, 1 upon 3 is equal to 0.333333. This is non-terminating. The division never ends. And another characteristic is this number 3 is repeated again and again. So this type of repetition is called recurring but non-terminating, and it is always recurring. Similarly, 3 upon 7 is equal to 0.428571. Then again 428571. So this pattern is repeated and it will go on repeating infinitely. So this is also non-terminating decimal and the pattern is repeated again and again. Now take 22 divided by 7. This is equal to 3.142857. Again 142857. Again it will be repeated. This pattern will be repeated and this is non-terminating. So we get two types of decimal numbers. Fractions expressed in decimal. There are two types. Number one is the terminating decimals. So all terminating decimals are rational numbers. Number two is non-terminating and infinitely recurring decimal. These two type of decimal numbers belongs to the rational numbers. So they are rational in decimal form. Originally they are fractions, but in decimal form their characteristics are, one is terminating decimal and another is non-terminating and infinitely recurring decimals. But all decimal numbers are not rational. Let us take one example. We know 22 divided by 7 is equal to pi, but this is not true. In fact, 22 upon 7 is approximately equal to pi, but not equal to pi. Where 22 by 7 is a rational number, pi is not a rational number but an irrational number, and pi does not belong to the rational number q. That we'll discuss later. So what we have learned, all decimal numbers are not rational numbers. For example, pi is actually a decimal number and that decimal number is not a rational number. So that we'll discuss later. What are irrational numbers? So basically we get four types of rational numbers. One is of integer form. For example, 1, -2, 0, etc. These are all integers, but they can be expressed in the form of p by q, but their basic form is integers. So all integers are rationals. And number 2 is fractions are already in the form of p upon q, so they are also rational numbers. In decimal form, terminating decimals are also rational numbers. And also non-terminating decimal with infinitely repeating patterns, these are also rational numbers. So all are rational, but just their patterns are different. All integers are rational because they can be expressed in the form of p upon q, and fractions are already in the p upon q, and terminating decimals can also be expressed in the form of p upon q, and non-terminating decimals can also be expressed in p upon q form. So we have learned about rational numbers. In the next part, we'll learn about irrational numbers.